Ever asked an AI a question and got an answer that sounds smart, but just feels off? Like it's confident, but maybe just making things up. That's what experts call an AI hallucination, when a language model spits out information that's plausible but totally false. And it's a big deal. So how do these hallucinations happen? Well, AI models like GPT or Claude don't think like humans. They're trained on massive amounts of text, learning patterns to generate responses. But when they hit a gap in their training data or face a tricky question, they'll invent answers, sometimes convincingly. Think of it like a student who's never studied a topic, but still gives a polished speech. The problem? Those fake answers can spread misinformation, especially in critical areas like healthcare, law, or science. Let's break this down. AI hallucinations fall into two categories. Intrinsic hallucinations occur when the model contradicts itself, like saying, the moon landing happened in 1969, and later claiming it was staged in 1972. Extrinsic hallucinations are when the model fabricates facts that don't align with reality, such as insisting Albert Einstein invented the light bulb. These errors aren't just glitches, they're systemic flaws in how models process and generate language. Research highlights specific manifestations: factual errors, e.g., claiming the internet was invented in the 1920s, contextual inconsistencies, contradicting itself in a conversation, and temporal disorientation, mixing up past and present, like saying a 2020 event happened in 2010. Even ethical violations, like giving fake medical advice, fall into this category. But why do these happen? 3 key factors. 1. Data issues. If the model was trained on outdated or biased data, it'll repeat those flaws. 2. Model design. Some architectures prioritize plausibility over accuracy, making them overconfident. 3. Prompt engineering. How we phrase questions can trick the AI into fabricating answers. Think of it like a student who's great at memorizing, but bad at critical thinking. If you ask, what's the capital of France, they'll say Paris. But if you ask, what's the capital of France in 1800, they'll panic and invent an answer. That's the AI version of a student guessing when they don't know. But scientists are on it. Let's break down how they're building guardrails to keep these models honest. First, they're getting better at detecting hallucinations. Tools like RAGAS evaluate whether a model's answer aligns with real data. Others, like TrueTeacher, train models to spot contradictions in their own outputs. And some researchers are even teaching models to say, I don't know, when they're unsure, like the approach in, where multiple models collaborate to flag gaps in their knowledge. Here's the kicker: it's not just about the models. The data they're trained on matters too. Papers show that flawed datasets can trick models into believing false information. So researchers are cleaning up training data and creating benchmarks, like FActScore, to measure how accurate models are over time. Now let's talk about the tools that actually catch these errors. Take Truthful QA. It's like a reality check for AI. Instead of just checking if an answer matches a textbook, it throws in tricky questions designed to trip up models with common misconceptions. And HalluLens. It's a detailed map of hallucination types, categorizing errors into factual, ethical, or logical mistakes. It's like giving AI a health check for different kinds of blunders. Then there's FActScore, which acts like a fact checker with a magnifying glass. If an AI summarizes a news article and claims, scientists cloned a dinosaur, FActScore flags that as a red flag. And Q2 and Quest Eval. They turn the problem on its head by asking questions about the AI's output. If the model says the Eiffel Tower is in Paris, Q2 might ask, where is the Eiffel Tower? And check if the answer matches the original text. It's like having a conversation to verify accuracy. But here's the real challenge. AI isn't just wrong, it's overconfident. Models often sound like they know everything, even when they're guessing. This is dangerous in fields like medicine, where a wrong answer can have real consequences. And our brains. We're wired to trust fluent, confident responses, so we need tools that force models to admit uncertainty. Researchers are tackling this with innovative solutions. Retrieval augmented generation. RAGAS teaches AI to double-check facts by pulling real data from the web, like giving the model a cheat sheet before it answers. Other studies tweak the AI's thinking process, making it more cautious when it's unsure. Meanwhile, benchmarks like MedHalt and MedHallu stress test medical AI with complex scenarios, ensuring answers align with real-world knowledge. But here's the twist: even the best models aren't perfect. Some studies show AI can be biased by the data it's trained on, or overconfident in uncertain answers. That's why researchers are building smarter guardrails, like reasoning checks that ask, does this answer make logical sense? And systems that cross-reference multiple sources. The road to trustworthy AI isn't easy, but it's full of creativity. By combining better detection tools, cleaner data, and models that admit uncertainty, scientists are making progress. And that's good news for all of us, because the future of AI depends on it staying honest. So next time you chat with a language model, remember, it's not perfect. But thanks to these guardrails, it's getting better every day. Stay curious, and let's keep pushing the boundaries of what's possible.